Hey guys, what's up? You are watching Physics Lab and today we are going to discuss TIFR GS-2018 physics problem. This problem is basically about thermodynamics. Very interesting problem. I have solved it before. Today I am going to solve it for you again. Okay, let's get started. A many body system undergoes a phase transition between two phases A and B at a temperature Tc, and the temperature dependent specific heat at a constant volume Cv of the two phases are given by. So they have given two specific heat at constant volume, phase A and phase B, and this is for phase A and this is for phase B. Okay, next they have given that assuming negligible volume change of the system and no latent heat generated in the phase transition, Tc is. So they are asking you to find out what is the temperature during the phase transition. We have to find out this quantity, and they have given four options. So basically what they have given is they have given specific heat before phase and specific heat after the phase transition. Okay, this is specific heat for phase 1 and this is specific heat for phase 2, specific heat at constant volume. Okay, and what else they have given you? Assuming a negligible volume change of the system and no latent heat generated in the phase transition. This is not very important, assuming negligible volume change, but this particular sentence here, no latent heat generated in phase transition, what does it mean? Usually during the phase transition the temperature of the system remains constant. Okay, the only heat generated in the phase transition is latent heat. Okay, latent heat of fusion, latent heat of vaporization, etc. But they have given that no latent heat is generated in the phase transition. So what happens to the entropy then? So there is an entropy change during the phase transition, right? So what is the formula for entropy? Delta S equals to final minus initial equals to integral of delta Q by T dt. So what is this delta Q here? This is latent heat generated during the phase transition, but they have given that no latent heat is generated during the phase transition. So what happens to this quantity? It becomes 0. So this whole integral becomes 0, and delta S, that implies SF minus SI equals to 0. SF equals to SI, or SA equals to SB. That means entropy before phase transition equals to entropy after phase transition. Okay, and how do our job is to calculate the entropy before phase transition and entropy after the phase transition. And how do we do that? Using these two quantities. They have given Cv of phase 1 and Cv of phase 2. Okay, using these two quantities we are going to find out entropy before phase transition and entropy after phase transition, and our problem is solved. Okay, let us do that. And what is that given? Cv A equals to AT cube plus BT, and Cv B equals to CT cube. Okay, this is entropy for phase 1, and what are we going to do to find out Ca equals to integral of Cv of A dt divided by T. Okay, and we are going to substitute the Cv value by T dt. Okay, now what do we get? Integral of taking the LCM, we get AT square plus B dt. We have to integrate it, it's no big deal. AT cube by 3 plus BT. This is entropy for phase 1. Similarly, we will calculate the entropy for phase 2 using this formula. Okay. Okay. Integral of Ct square dt is equals to C T cube by 3. This is entropy after phase transition. Okay, but SA is equals to SB. We have to equate these two quantities. Okay, A T cube by 3 plus BT equals to C T cube by 3. That implies BT equals to C T cube by 3 minus A T cube by 3. Okay, that implies B equals to, taking the T common, and we have to cancel that. We'll be getting C minus A by 3 into T square. Okay, now where are we? B equals to C minus A by 3 into T square, and 3b divided by C minus A equals to T square, and T is equals to root over 3b divided by C minus A. This is nothing but temperature during the phase transition, and let us see our options what they are. This is option number C, 3b by C minus A. So that's what we got here, right? So that's how you solve this problem. So what is the algorithm or the trick to solve this problem? They haven't mentioned anything about entropy in the problem. If you see here, see, nowhere in the question they have mentioned about entropy, but they are just giving you the hint here. No latent heat is generated in the phase transition. Seeing that, you have to assume that entropy will be constant, so that I'll be finding the temperature of phase transition using these two quantities, specific heat at constant volume before the phase transition, and specific heat at constant volume after the phase transition. So that's how you do the problem. Once you know the trick, it is no big deal. You just have to calculate, you know, the formula for entropy, and you will be calculating entropy easily. Okay, and equating the entropy, and finally you will get this answer. Okay, hope you enjoyed this video. Keep learning. Happy physicsing. Stay curious. Bye bye.